Hi, so this is just a continuation for my discussion on the first topic of the Unit 5. Now we are on the topic 2, which is all about the crust. So, meron na tayong background information on the characteristic of crust kasi nga we already discussed that one on the first topic of the Unit 5. So, for the objectives, we have here identify the general characteristic of the crust. Second one, differentiate continental crust and oceanic crust. So I know that you already have an idea of the difference between oceanic crust and continental crust. Not only with the type of composition each of these crusts have, but also the place or the location na atong makitaan si continental crust and oceanic crust. So what are the distinct features of the Earth's crust? Now, crust, or let us consider first the general characteristic of the crust. So crust is the outermost layer of the earth and is the only layer where organisms are found. This layer makes up less than 1%, so 1% lang siya class of the earth's total volume. So imagine ang mga yuta nga usahay pag-awayan pa dyan sa mga magsuon or pag-awayan pa dyan sa mga relatives comprises only of 1% of the Earth's volume, total volume. So, can you imagine that? So, wala lang, ma-amaze lang ko nga, ingana good, for just 1%, tapos ang mga tao kay mag-away-away pa dyan just because of mga away sa yuta or ingana. So, this rigid layer is in the constant process of destruction and renewal, wherein new crust is formed in oceanic ridges, while some are subducted through the mantle. Now, this is the unique characteristic of the Earth's crust because wala lang siya nag-exist infinitely, but instead, it is on the process of constant renewal and destruction. Maguba siya, then mag-renew na po, and then mag-deform na po siya, then mag-renew na po, then na po la information na ma-form. Yan. That is the unique attributes of crust. One of the parts of the Earth's tectonic plates is the crust. Tectonic plates are slabs of brittle lithosphere, which can able to move due to the plasticity of the underlying asthenosphere. Most of the seismic activities during earthquakes happen near the boundaries of these plates. The crust is divided into parts, continental and oceanic. So, ang tectonic plates class, mura na siya gana mga pikas siya na parte ng crust. So, for example, let us take a look first on here, during a portion sa Arabian plate, this one. So, kining Arabian plate and Antarctic plate are usually separate. So, wala na sila nagkadugtong class. Even though makita nato nga, sumpay lang sila in a way, silang land formation, but actually, wala na sila nagsumpay underneath. Kasi nga, merong boundary nga nag-exist among the two. Same also with the North American plate and the Eurasian plate. So even though yung land formation or geographically speaking, makita nato nga sumpay lang ilang mga mountains, sa mga forest, but underneath those forests or those mountain formation that they have, nakaseparate na siya underneath sa crust or just below the crust. And these tectonic plates constantly moves due to the plasticity of the underlying asthenosphere. So kasi nga si asthenosphere plastic yung physical state niya. So constantly lang na siya class naga-move, tapos matandog lang gani gamay si lithosphere class. Mo relay na day na siya or mo release na day na siya energy padulong sa crust, padulong sa pinaka topmost layer sa crust. So mao na makasinati taog na ay medium movement sa ato ang underground. That's because the movements of the asthenosphere actually affects the brittle lithosphere. Merong slabs of forces na nangyayari kaya yung energy nata-transfer siya from one layer to the different or to the next layer. Okay, so continental crust, balik-balik na pod class. So they makes up the land surface of the earth, which is about 32 kilometers thick, but may reach up to 70 kilometers thick in mountainous areas. That is the unique characteristic mangod for continental crust class kasi they're able to form mountainous formation, mountainous creation. Like for example, Mount Everest, the Himalayas, the Chocolate Hills. So these are the amazing movements of continental crust. The composition is more variable than oceanic crust but can be generalized as mostly granites. So granitic colors are generally light-colored igneous rocks. So light-colored class ha, basta granite, they are light-colored igneous rocks which have relatively low density. So granites compared with the basalts or basaltic rocks have lower density. So that means they are lighter compared to basalts. Mas magaan sila compared sa basalt. Mas magaan si granites. The continental crust is located at higher elevations and above the sea. Kaya nga yung continental crust, makita nato siya kasagaran sa different continents. Dili nato siya makitaan below the sea or on the ocean floor. It's because oceanic crust naman na siya. The continental crust is located at higher elevations. Nasa matataas na lugar siya and above sea level because of its greater thickness and lower density compared to oceanic crust. It is also relatively older, so mas matanda si mas matanda yung mga rocks ni oceanic crust mas matanda yung mga rocks ni continental crust compared kay oceanic crust. In fact, the oldest known grain found in the continental crust is about 4 billion years old, in contrast to the oldest oceanic crust, which is only 200 million years old. The continental crust can come from several continental features which are grouped into two categories: the mountain belts and stable interiors. Continental crust are formed by these two group of categories, the mountain belts and the stable interiors. Mountain belts are uplifted regions of deformed rocks. These are formed through orogenesis or mountain building events. An example of a mountain belt is the Himalayas that was formed by the collision of the Indian plate and Eurasian plate. Interestingly, the highest peak of this mountain range is the Mount Everest. So, continental crusts are formed by these mountain belts. So, kung mag-abot class si Indian plate and Eurasian plate, na ay ma-form ana ng mga continental crust. Specifically, another type of mountainous area. That is why ang Himalayas current class, specifically the Mount Everest, they are continuously growing. Kasi nga, continuous man po nga naga-converge or naga-abot or naga-collide si Indian plate and Eurasian plate. That is why pataas ng pataas yung mga Himalayas mountains, specifically si Mount Everest. The next categories that gives way to the formation of the continental crust is the stable interiors. The stable interiors are older, so mas matanda sila kaysa sa mountain belts or itong uplifted region of deformed rocks. So within these areas are expansive and flat regions which are composed of deformed crystalline rocks called shields. In some cases, areas of the stable interior with deformed rocks are covered with thin layer of sedimentary rocks which are called stable platforms. For example, for this one, we have here the different shields. So, all throughout our continents, or the 7 continents, meron tayong tinatawag na shields. So, the shields, they are these deformed crystalline rocks. So, thus, the deformed rocks are covered with thin layer of sedimentary rock. So that means class nga ang shields o si stable interior mag-abot na sila na isa sa ilamang pa ibabaw tapos na po isa sa ilamang pa ilalom. And that gives way to the formation of stable interiors which then translate into becoming continental crust. Alright, so always remember lang that under stable interiors, it can be that it can be also nga dili mag-abot si shields and stable platforms because in most cases, stable interiors are formed purely from the shields kasi nga they are the deformed crystalline rocks. Tapos on the other hand, meron ding stable interiors na galing siya sa deformed rocks that are covered with thin layer of sedimentary rocks which are then called as stable platforms. So it could either be nga si shields diha lang siya na area tapos si stable platforms diri lang po siya tapos na po in some cases mag-abot na silang duha tapos na ay duha sa ilahan na magpaibabaw tapos ang isa is magpaubos. So that is another mechanism of the creation of continental crust that is the stable interiors. Okay. So next one is the oceanic crust. Oceanic crust is a thin layer. Medyo manipis lang siya, averaging from 5 to 7 kilometers thick. It is consist of mafic rocks, which are made up of silicates, magnesium, and iron. An example of mafic rock is basalts. So basalts are rocks that are mainly made up of calcic, plagioclase, and pyroxenes minerals that are usually dark in color. So compared with granites, kasi nga si granites, they are mainly made up of, the appearance of granites are usually lighter. So basalts, which are the main components of oceanic crust, are darker in color. Aside from that, oceanic crust is denser. So that means mas mabigat si oceanic crust compared kay continental crust. Oceanic crust is denser than continental crust and occupies areas of lower elevation covered by oceans. Kaya nga hindi masyadong tumataas ng elevation si continental crust because mabigat siya. Compared kay continental crust niya, they can reach up to the highest elevation nga maduol na siya sa clouds, ingana sa atong atmosphere. Dili na siya possible kasi nga mahitabo kay oceanic crust kasi nga bugat si oceanic crust. Si continental crust, gaan lang siya. So the difference in density, so that is why si oceanic crust, they are just covered by the oceans. The difference in density is the reason why oceanic lithosphere subducts upon collision with adjacent plates, wherein the region of subduction produces trench. Just like continents, the ocean floor also hosts some features including canyons, trenches, and volcanoes. Ang trench class, mura rin po na siya sa katunay tabo sa Himalayas good nga. Once ang Eurasian plate o ang Indian plate mag-abot o mag-collide sila, na ay continuous formation or na ay mountain building formation mahitabo. Now, when this happens, under the ocean, ang tawag ato niya is trench. Kasi nga naapoy times nga mag-abot ang different types of, different plates of oceanic crust. So, naay trench or naay kanagong naay medyo sanay. Ang trench man good class, ang trench if naa siya sa continental crust mahitabo, mo nang ginatawag nato mga mountains or kanang mga different mountain formations. Now, if if kana siya mahitabo sa ocean, na po ginatawag ng mga trench ang ocean nato ka mga wala gyud siya mountain, however naa lang siya na locate sa ocean. Ana. So, ocean floor host for canyons, host some features including canyons, trenches, and volcanoes. Meron din volcanoes kasi na form under the ocean. Specifically sa Japan class, they have volcanoes that are active underneath their oceans. Continental margins are the areas which separate the continental and oceanic crust. So from the word itself, margin, so that means it is the boundary between continental and oceanic crust. It includes continental shelf, continental slope, and continental rise. The continental shelf refers to the gently sloping platform extending seaward from the shore. These are the flooded extensions of the continents. Nasaan ako na ba yung picture na? Okay. Now, ang continental shelf class, mo ni siya ang area nga maabot sa dagat. Kanang bali ma-flooded siya ba or maabtan siya tubig sa dagat. So that is called the continental shelf. Before ka maabot sa oceanic crust, napakaagian na mga boundary, and that includes the continental shelf. Now, next one to continental shelf is the continental slope. So, continental slope is the area where the boundary between the continent and the ocean basin lies. It is a region where the angle of descent becomes steeper and reaches up to 4 km in depth. Okay, tanaw ta diri sa diagram. Now, ang continental slope class is the boundary for the continental crust and the oceanic basin. Ito, kaya matatawag natin ito na continental slope. Bali na ay gradual sana ay rise ba before ka makaabot sa oceanic basin, you need to go through to the continental slope. The next one is the continental rise. Continental rise is a gradual incline in regions where trenches do not exist. So in this portion, so in this diagram class, continental rise, duol na siya gamay sa oceanic basins. Like, sa ako magong na-learn pag college, ani kay dapat mag-una si continental rise, continental slope before ka mo-continental shelf. Now, for example, let's just consider my learning the part of the continental margin, if magsugod ta sa oceanic floor, dili na portion, before ta makaabot sa coast, or before ta makaabot sa continental crust, nga ito makitaan sa kanagong unahan sa dagat class, nga kanang wala na itubig na, pero unahan niya mga beach or beach resort balik. So before ito makaabot ang portion, we need to go through this three distinctive na mga parts or distinctive na where division of areas. So the end of the oceanic basins, before ka makabot sa crust, burag bali naalay rise gamay. So di ba man ni siya ang end sa oceanic basin, tapos musaka lang gani siya gamay, mo na siya ginatawag na continental rise. Bali murag padulungay pa lang ka, musakaay pa lang ka, mo na siya ginatawag na continental rise. Now if mupasaka na jud ka padulong sa continental crust, mo na siya ginatawag na continental slope. Kaya murag ano man jud nimo ni ano jud ka ba sa tawagan ng nitungas jud gani ka para makaabot ka sa continental crust. Now, before ka makaabot sa pure continental crust, you need also to consider continental shelf. Continental shelf is the portion after continental slope. So after nakatungas na sa pinakaibabaw, tapos after wala na jud kay tungason lain, kay murag na ka sa pinaka-peak sa imong pag kintahay, kay the rest mura naman siya plain, linear naman lang siya, wala naman kay basta mo siya tungason good So since plain naman diri nga area, so that means you already attain your continental slope. And the next one, ano siya ginatawag na continental shelf. So continental shelf pertains to the areas nga maabtan og tubig dagat. So from this point, since mao ni siya ang area nga dili na ta makatungas, kay since medyo linear naman siya, medyo plain naman siya, dili naman siya, wala na may elevations nga nahitabo. So ang area nga maabtan sa dagat before maabot sa coast, mao na siya ginatawag na continental shelf. So again, from this ocean basin, pag ang mag-end ang ocean basin diri tapos mo-rise lang kagamay, musaka lang kagamay, man siya ginatawag na continental rise. Now if busaka jud kag maayo hangtod maabot nimo ang peak, mo na siya continental slope. Now the next one, if wala na peak lain tapos pa straight line na lang siya padulong sa coast, now that is the area for continental shelf. Kanang maabtan siya og oceanic waters. Okay, that is the part for the continental margin. Meanwhile, deep oceans lie between continental margins and oceanic ridges. Seamounts and abyssal plains are found in these regions. On the other hand, oceanic ridges are composed of layers of igneous rocks that have been uplifted. These are the site of formation for new oceanic crust. So, ang deep ocean basin, it just lie below the continental margins. So, if this is the continental margin, below that one is the deep ocean basin. Okay, so as what I have mentioned, class, ang ridges, if sa continental crust, ang ridge mo compare na to siya sa mountain formation here in the oceanic crust, bali mura po siya mga ridges or bali mura siya mga mountain. However, nalang siya nahitabo sa ilalim sa dagat. And they are not called as mountain formation. Instead, they are called oceanic ridges. Oceanic ridges are formed from the materials that came out in this point or the gap between oceanic or between plates of oceanic crust. Since mag-diverge man sila or magbulag sila, mo na gap at the center. Tapos, diha sa diha nga gap, magawas ang mga molten rocks coming from underneath here in this portion, then that gives way to the formation of new oceanic crust. So these are the different parts of oceanic crust.